Hey everyone, so in this video, we are going to talk about the volume of two unique, you could say pointy in some parts, shapes, and that's cones and pyramids. And if there is two three-dimensional figures that Miss Walker sucks at drawing, it is cones and pyramids. So I did my best. If you need to Google a picture of a cone or a pyramid to help you with your three-dimensional drawing because my pictures just aren't doing it, I will not be offended, but you might want to take a moment right now to pause the video so you can get your pictures drawn for this. And then we're going to go over the formulas for how you find the volume of a cone and a volume of our two different kinds of pyramids. So go ahead and take a moment to draw a cone, which if you need help, think about an ice cream cone. That's essentially what this is. Square pyramid is, if you think about like the pyramids in Egypt, if you've ever seen pictures of those, or you could Google pictures of those, that is what a square pyramid is. Triangular pyramids are very similar to square pyramids, except the bottom part, the base, is a triangle. So it's also called a tetrahedron. That's another word that we use or that we can use for a triangular pyramid. This figure right here is probably the easiest way for you to see it. It kind of looks like a square pyramid, but it's supposed to be a triangular one. So a really easy way to draw pyramids if you need help is to draw the base shape. So draw either the square or the triangle and then pick a point. So I'll kind of draw another square pyramid so you can see. So draw yourself a square and then pick a point somewhere, like anywhere, but like kind of off to the side of the square. So I always kind of like to do up at the top and then draw lines to each corner of the square. So a corner here, a corner here, a corner here, and a corner here. And you can do the same thing with that triangular pyramid. Draw a triangle, pick a point somewhere outside, and then draw a line to each part of the triangle. Doesn't always look the best, but you can kind of see it. Again, if you need to Google, go ahead and Google. But go ahead, pause the video, or maybe I talked a lot in explaining this. So if you've had them all drawn, just hang tight for like 2 seconds and then we'll go over the formulas. Okay, so we are going to go over the formulas for volume of pyramids and cones. So that's the title of this notes page if you don't have it written down. Cones, the way that we are going to find the volume of a cone, or something that's unique about a cone's volume, it kind of relates to a cylinder. So a cylinder is a shape that has two base shapes of circles, and then it kind of has a rectangle wrapped around it. So cones actually have 1/3 the volume of a cylinder with the same base shape. So for example, if I drew a cylinder that had the same dimensions as this circle, like let's say the radius is 1. If I drew a cylinder in the same height as well. If I drew a cylinder that had the same dimensions of the circle and the same height, the volume of this cone is 1/3, or divided by 3, right? The amount of the cylinder. So 1/3 the volume of the cylinder with the same base shape and height, technically. So the formula is we're going to take the volume for a cylinder, which is just pi r squared times the height. So we need our radius. So I'm going to draw the radius. And then the height is going to be from the top point of the cone, or the bottom of the cone. If you think about it like upside down, like it's an ice cream cone, that's the height of the cone. So it's the area of the circle, pi r squared, times the height of the cone. But then we take 1/3 of that amount. So you can either multiply it by 1/3 or you could divide this value by 3, whichever one works. So that's how we find the volume of a cone. We take 1/3 the area of the circle times the height of the cone. Pyramids are related to our square, rectangular, and triangular prisms in a sense that they have 1/3 the volume. I'm just going to put of corresponding prism. So if you have a prism that has the same base shape, dimensions, and the same height, the prism's volume is going to be 1/3 of that particular, the pyramid's volume is going to be 1/3 the amount of that particular prism. So when we want to find the volume of a square pyramid, where the bottom or the kind of the base, the part touching the ground or the table or a surface, if you want to think about it that way, is we're going to take the area of a rectangular or a square prism, which is just length times width times height, and we're going to find 1/3 of it. So to find the volume of a square pyramid, we just take the length, the width, and the height. So length, width, and then height. I hope you can kind of see what I'm doing here. Height is the measurement from the top point of the pyramid to the base shape, kind of where it meets the base shape perpendicularly or at a right angle. That's the height of the pyramid. So we take length times width times height, and we find 1/3 of it. So we divide it by 3. Triangular prism, it's the same thing. I'm going to use this one over here to kind of model. So the height, again, is going to be where from the top point of the pyramid to the base triangle meets at a right angle. That is the height of the pyramid. And then with the base shape, I'll just draw another triangle here. You know, we always have our base and our height of our triangle. So to find the volume of a triangular pyramid, we are going to do 1/2 base times height. So so the area of the base shape, so the area of like the bottom triangle, times the height, capital H, times the height of the pyramid. But we're also going to take 1/3 of it. And the reason why we're doing this is if I had a triangular prism that had the same base triangle as this pyramid, or as this pyramid, or as this pyramid, and I found the volume, and then I found the volume of this particular pyramid, the difference between the pyramid and the prism is that the pyramid's volume is 1/3 of the prism. So if you want to simplify this formula so that way you don't have to have 2 fractions, another way to think about it is if we combine these fractions together, it's the same thing as 1/6 base times height times H. So that way, if you don't want to work with 2 fractions, you can kind of just do it this way. If it's easier for you to find this and then divide it by 3, you're totally welcome to do that. Or this one also works, just so you know. So either one of these is good for the volume of a triangular pyramid. I keep wanting to say prism, but I'm talking about pyramids here. So essentially, with cones and with pyramids, nothing about the volume really changes, except depending on the shape, we just take 1/3 of that amount. So if we're working with the cone, we're essentially finding the volume of a cylinder, but then taking 1/3 of it. And then with pyramids, we're finding the volume of a rectangular prism and then taking 1/3 of it. We're finding the volume of a triangular prism and then taking 1/3 of it. That's kind of the difference between these particular shapes compared to the prisms. So make sure you have these formulas down. I'll stop here so that way if you didn't get the bottom part, and make sure you utilize them when you're doing your practice and your homework. Have an awesome day.